So hey guys, in this video we are going to solve a problem based on what? The separately excited DC motor. So we are going to find out the voltage and the current of that particular separately excited DC motor. Let us read the question. So this will be quite big, but the thing is that we are going to note down what all the things are given. Okay, a 15 HP 220 volt 2000 RPM separately excited DC motor. That means these three values are nothing but what? The rated values of the motor. Okay, so controls a load requiring a torque of what? TL 45 Newton meter. TL is given low torque, which is same as the developed torque by the motor also. So TL it is given as 45 Newton meter, which is the unit. It can be also written as what? TD, the developed torque. Simple. Now it is running at a speed of 1200, which is less than the rated speed 2000 rpm. Okay, so that is also there. So this is the main thing, and we are going to take the running, whatever it is running at, it is 1200 rpm. So what you are going to write, it is basically omega, speed of the motor. So instead of writing n, we are going to denote it as omega, speed of the motor, speed of the motor at which it is running now. Now next, the field resistance, circuit resistance is also given. Rf is equal to 147. So we are going to write Rf is equal to 147 ohm. Then the armature resistance Ra is equal to also given. Ra is also given. Then and the voltage constant of the motor kV. kV is also given. So kV we are having here, which is how much? 0.7032. This is the kV given value. Volt per ampere, radian per second. Okay, unit of that. The field voltage is also given. Vf is also given. So beside Rf, I am going to write Vf. The field voltage 200 volts. Sorry, 220 volts. The viscous friction and the no-load losses are negligible. That we can leave it out. The armature current may be assumed as continuous and ripple free. Okay, so this is the main part. Determine. So we are going to determine the what back EMF of the motor, which is Eg. The first thing we are going to find out. Then second thing is the armature voltage Va. Third is the rated armature current. Rated armature current. Okay. So these all things we are going to find. So we'll proceed with the first part, which is basically to find out the Eg. Now what is the formula for Eg? Simple formula we have to remember, which is Kv omega into If. Okay. So this is what we have to find out. In this kV it is given, yes it is given. Omega whether it is given, it is given. But the thing is that in formula while substituting, remember you have to convert it into radian per second. So whenever you are substituting the speed, always convert into radian per second. So how will you do that? So let us, kV is already given. Okay. So we are first finding omega. Omega is 1200, which is in RPM. In order to convert into radian per second, what you have to do? Just you have to take 1200 multiply with pi by 30. This is what you are going to do. Or one more option is that you can multiply with 2 pi by 60 also, which means the same thing. Some of them will be using 2 pi by 60. So it's better to use pi by 30. So you can remember just pi by 30. You have to convert it into radian per second. Okay. This is the unit we want. Now omega also done. Okay. Next IF. What will be IF? IF is the field current. Field current is not given in the question. We can see all these values we can see. But the thing is that RF and VF is given. So how to find IF? IF is equal to VF divided by RF, we can say, which is nothing but I is equal to V by R. That's it. So what is the VF given? 220. What about IF? 147. So when I divide both this, I will be getting 1.49 amperes. So I got IF also. Now I can directly get the value of back EMF Eg. Substitute. So kV value is 0.7032 into omega value is 1200 into pi by 30. If you want, you can convert and keep it. Okay. Into 1.49. So when you solve this part, you will be getting the answer as 132.25 The unit is volts. So this is the EG value. First part of the question done. Let us now go for the second part of the question. We have to find the armature voltage VA. So VA, remember what is the formula we are going to use? It is IARA plus EG. So EG we already found out, that the previous case. IARA, now RA is given. You can observe over here, RA is given, but IA is not given. How to find the armature current? Armature current, in order to find, we have to basically go for the torque equation. So remember, the developed torque, which is TD, is equal to KT into IF into IA. This is the formula. Okay. KT will be same as, this is the torque constant, like we are having here voltage constant, right? This will be same as the torque constant. Okay. So this particular thing you remember. Next. So we can, in place of KT, I can write KB also. So I will just write it as KB because both will be same. Voltage constant and torque constant. Now here we are having IA, so I need IA. So IA is equal to what? TD divided by KV into IF. Now how to find TD? TD is already given in the question. You can observe that 45 Newton meter. So I am going to take 45 divided by KV value is 0.7032. IF value we found out, which is 1.49. So when you substitute these values, you will be getting IA value as 42.7. In order to get VA, IA which is 42.27, 42.7, RA value is given as 0.25 plus EG value we got it 132.25. So you will be getting the VA answer as 142.9 volts. 94 something will be getting. Okay. So you can write it as 143 also. Armature rated current. Okay. So armature rated current, how to find? Very simple, using the equation of power. See, it is asking rated. They are not asking about IA. There is IA sitting. See, we found out IA. They are asking about the rated. So rated values will be found out from the rated values only. So what is the rated values given? 15 HP, 220 and 2000 RPM. So 15 HP is nothing but the power they are talking about. So here the C part is to find out I rated values. So we have given that power is equal to 15 HP. So 1 horsepower. So 1 HP is equal to what? 746 watts. So you can convert the power into watts itself. Yes, you can convert. So that is fine. So power will be equal to 15 into 746 watts. So power we are having. Okay. So what will be the equation of power? Power is nothing but V into I. Simple equation. This I can be rated, said as what I rated. That means V rated into I rated. That's it. V rated into I rated. Now in order to find out I rated, I have to just shift V rated there. So it will become whatever the power is there divided by the V rated. What is the V rated value given in the question? P is nothing but 15 into 746, and the V rated value, if you observe, as I have said here, it is what? 220. So it is 220. So you will be getting the answer as 50.86 amperes. So I rated, be careful, I rated is different from IA which we are finding out here. Okay. So this is the final answer. So this is how we have to do. So remember these formulas. This is very important formulas. Okay.